about that? Guys, we're so sorry you have to see that, and yeah, we're too noisy. Josh is playing the drums, and we are doing our own thing, doing phone. We are the B6, but we are often called the Atomics because we are so atom.
We are so atom.
It's because of our logo. It's atom, and we are here to discuss the model of Niels Bohr, which is the planetary model of atom. And yeah, let's get into this. I'm Janine Gonzalez, and I'll discuss to you the history of the planetary model of atom of Niels Henrik David Bohr. The planetary model of atom, or Bohr's model of atom, was proposed by the Danish physicist Niels Henrik David Bohr in 1913. Bohr's atomic model is a system which is the nucleus, or the dense nucleus, was surrounded by the electrons, similar to the structure of the solar system. Labeled by an integer, which is labeled by the quantum number n. Electrons can jump from one orbit to another by emitting or absorbing energy. And that's it for the history of the planetary model of atom, and let's proceed to the next.
So hi guys, I'm going to introduce the diagram and the explanation of Bohr's planetary model of atom. So let's go now. So this is Bohr's atomic model of a nitrogen atom. So in the center, it is the nucleus. It is composed of proton and neutron. So it is surrounded by electron orbits, which is of course composed of electrons.
This is also Bohr's model of nitrogen atom. Electrons travel in defined circular orbits around the nucleus. The orbits are labeled by an integer, the quantum number n. Electrons can jump from one orbit to another by emitting or absorbing energy. The inset shows an electron jumping from orbit 3 to orbit 2, emitting a photon of red light with an energy of 1.89 eV.
So that's all for the diagram of Bohr's model. So let's go to the ideas proposed by him.
So I'm going to discuss the idea proposed by Niels Bohr regarding the atomic structure. The Bohr model and all of its successors describe the properties of atomic electrons in terms of a set of allowed possible values. Atoms absorb or emit radiation only when the electrons abruptly jump between allowed or stationary states. Direct experimental evidence for the existence of such discrete states was obtained in 1914 by the German-born physicists James Franck and Gustav Hertz.
Immediately before 1913, an atom was thought of consisting a tiny positively charged heavy core called nucleus, surrounded by light planetary negative electrons revolving in a circular orbits of arbitrary radii.
Bohr amended that view of the motion of the planetary electrons to bring the model in line with the regular patterns or spectral series of light emitted by real hydrogen atoms. By limiting the orbiting electrons to a series of circular orbits having discrete radii, Bohr could account for the series of discrete wavelengths in the emission spectrum of hydrogen. Light, he proposed, radiated from hydrogen atoms only when an electron made a transition from an outer orbit to one closer to the nucleus. The energy lost by the electron in the abrupt transition is precisely the same as the energy of the quantum of emitted light. So that's all for the idea proposed by Niels Bohr regarding the atomic structure.
I'm going to discuss the similarities and differences of Bohr's model from other models. Each models have different representations of atoms. The difference of Bohr's model from other models is that Bohr's model has a definite orbit for electrons. Also, the places of neutrons, protons, and electrons vary. Furthermore, each model has its own proponent.
For the similarities, John Dalton and Democritus share the same idea of atoms being indivisible particles. Bohr's model is similar to quantum mechanical model of Heisenberg, but the quantum mechanical model has no definite orbits. It is also similar to Rutherford's since the neutron and proton are located at the center, while the electron is surrounding the nucleus. So that is all for the similarities and differences of Bohr's model to other.
In conclusion, all proponents discuss their own thought or theory regarding the atom. All of the models refer to the past models, but as time passes by, it is further improved and modified, and therefore, they are all interconnected.